Hey guys, in this lesson we would understand how to describe transformations in quadratic relations. Now before describing transformations, we should first understand that whenever the quadratic relations are given in vertex form, then only we'll be asked to describe the transformations. So transformations are possible for vertex form of quadratic relation. That's the first thing to remember, and second thing to remember is the general equation of the vertex form of quadratic relation. And that is y equal to ax minus h square plus k. So any given question, we would write it down such that it represents the general equation like this. Here a, h and k, they are called the transformation parameters. Whenever we will be asked to describe transformations, we will be asked to describe these transformation parameters. We already understood the meanings of a, h and k in the previous video lesson. However, we would quickly summarize it here as well. If a is given in a quadratic relation, it shows that the graph is going to be vertically stretched or vertically compressed by a factor of a. And when is it going to be vertically stretched is when a value is greater than 1, it's a vertical stretch. When a value lies in between 0 and 1, it's going to be a vertical compression. One more thing a is going to describe is if a is negative, then it will represent reflection over x-axis. If we're given h in the vertex form of the equation, so then h describes horizontal translation by h units. And what is the scenario? If h is a positive number, then it is horizontal translation by h units right. If h is negative, then it's horizontal translation by h units left. This is how the transformation parameter h is described. Next we have is k. K describes vertical translation by k units. If k is positive, graph is vertically translated by k units up, and if k is negative, graph is vertically translated by k units down. Let's understand all these transformation parameters better using examples. So the first example we have is y equal to 2 x minus 1 whole square plus 3. Now the first step is always to write down the general form of vertex quadratic equation. So the general form of vertex quadratic equation is y equal to a x minus h whole square plus k. From here we can match the a, h and k in the given example, and we know a would be equal to 2, h would be equal to 1, k would be equal to 3. Now since we have to describe these transformations, so we would write down a equal to 2 here. Because a value is greater than 1, that means the graph is going to be vertically stretched by a factor of 2 units. And a is not negative, so that means there is no reflection. So we just have to describe the value of a that is greater than 1, and that has been described with vertically stretched by a factor of 2. Next we have h is 1. H is 1 means h is a positive one. So we would write down graph is horizontally translated 1 unit right. Similarly, we can describe k value that is equal to 3 because k describes the vertical translation. So k equal to 3 means graph is vertically translated 3 units up. That's how we describe the transformations. Let's take up another example for the sake of practice. If we're given an equation y equal to negative 3x squared and we are asked to describe the transformations for this, we first write down the general form of transformed quadratic equation, and that is going to be y equal to a x minus h squared plus k. Now, how do we find out what is a, h and k? Because the given question does not exactly match the general form. So we notice this negative 3 is being multiplied with x squared. It's in front of x squared. Therefore, a value is definitely going to be negative 3. As we do not see anything inside the bracket with x, so that means h is not there and k is not there. So if h is not there, it's a 0. If k is not there, it's a 0 as well. When h and k are not 0, that means we are not supposed to describe h and k. We only have to describe the value that is given to us, and that is a value. So a equal to negative 3 means a is equal to 3 and a is also negative. A is equal to 3 means a is greater than 1. Therefore, we would write down that the graph is vertically stretched by a factor of 3. And a is negative means the graph is reflected over x-axis, or we can also write down that the graph opens downwards, because reflecting over x-axis means instead of looking like this, the graph is going to look like this, and this means the opening is downwards. And that's it for this particular question, because we do not have any h or k, so we don't have to describe any of those. Let's say the next example we have is y is equal to 1 over 2. In the bracket we have x plus 3 whole square. General form we have is y is equal to a x minus h square plus k. We can clearly see that a is 1 over 2. H is negative 3. Why is that so? Because the sign in the general equation is supposed to be negative, whereas the sign in the question is positive. So H is always taken with an opposite sign. If you're given plus 3, that means H is negative 3. K is again not given to us, so K is 0. Now we're describing A and H only. A is half means A is in between 0 and 1. So this would mean vertical compression by a factor of 1 over 2. H is equal to negative 3 means the graph is horizontally translated 3 units left, and we do not have to describe K because K is not there. So this would be the final answer for this type of question. Let's take up one last example, and the question we are given is y equal to x plus 2 whole square minus 4. We know the general equation is y is equal to a x minus h square plus k. Now a is not there. If a is not there, always remember it is not a 0, it is a 1. H is opposite sign, so it is a negative 2 in this case, and k is the same sign as it is given to us. It's a negative 4. Now when a is 1, we are not supposed to describe a, because a is 1 is same as what it is supposed to be in the parent equation. So remember, when a is 1 or h is 0 or k is 0, we are not describing any of these transformations. So we would start describing h. H is negative 2 means the graph is horizontally translated by 2 units left. K is negative 4 means graph is vertically translated by 4 units down. And this is how we describe transformations whenever we are given a quadratic equation in vertex form. One more thing here to remember is, if let's say we're given a question like this, y is equal to x squared plus 1, how do we decide if this 1 represents an h value or a k value? Now when we write on the general equation, we notice that a is something that is written in front of x square and it is being multiplied with x square. We don't have any number here that is being multiplied with x square, so a is not there and a is 1. H is anything that is within the bracket with x and is also squared with x. Here we do not have any number that is written along with x and is squared with x. So therefore, in this particular case, a is 1, h is 0, and this number would represent k. So k is positive 1. So in this type of a question, we are just describing k, and that is vertical translation 1 unit up. And this is how we describe transformations whenever we are given quadratic equations in vertex form.